Let's take a look at the process of simplifying rational expressions. Suppose we have the expression 10x cubed divided by 15x squared. I can simplify a rational expression by canceling common factors from the numerator and the denominator. So if we look at this expression for a moment, we can see that 10 and 15, they have a common factor of 5. 10 is 5 times 2, and 15 is 5 times 3. And so if you think about it for a moment, 5 divided by 5, 5 divided by 5 is just equal to 1. So essentially what we have here is just 1 times the rest of the expression. So 5 divided by 5 is really just 1 times the rest of the expression, 2x cubed divided by 3x squared. And so we can simplify the rational expression if I can identify something that's multiplied by the entire numerator, and if that same thing is multiplied by the entire denominator, then I can simplify the rational expression and write it, without that factor, without that common factor. So 10x cubed divided by 15x squared is equivalent to 2x cubed divided by 3x squared. But what's more, the variable part can be simplified in a similar way. X cubed is really just x times x squared. So I have a common factor, whatever x is, whatever that number represents, x squared up top and x squared in the denominator represent the same thing. And so those cancel with one another. Because we had x cubed in the numerator, there is one x left behind, and we end up with 2x over 3. So looking at number factors, if there's a common number factor among the coefficients, I can cancel that. So the 5 over 5 became 1, and I could simplify the expression by removing that factor. And in a similar way, if we have a variable, I can take sort of the smaller exponent from the top and the bottom. So we can cancel 2 x's from the top and the bottom, and it leaves 1 x behind, and the expression becomes 2x over 3. So I'm going to look at a couple other examples of this. Let's say we have 3v minus 12 divided by 3v. A word of caution, we have to make sure that we only cancel common factors. V and 3v is not a common factor because v isn't part of both of the terms up top. So v isn't multiplied by the whole expression. It is multiplied with the 3, but it's not multiplied with the 12. We can simplify this, however, because 3 is a common factor of all the numbers. So if I factor out a 3 from up top, I'm left with v minus 4. I have 3v in the denominator, and so now 3 is something that's multiplied by everything else. So 3 is multiplied by both of the other terms, v and minus 4, and 3 is multiplied by v in the denominator, and so I can simplify the expression. It becomes v minus 4 divided by v, canceling those 3's. Again, I can't cancel the v's because v is not a factor of the second part of the expression. V is not a factor of that second term. So factorization is an important thing to keep an eye on when you're working with rational expressions. Creating common factors, factoring expressions can sometimes help us simplify what we're looking at, what we're working with. So a larger example of that would be m squared minus 8m plus 15 divided by m squared plus 3m minus 18. There's no common factor. M isn't a factor of all of the terms up top, and neither, in the denominator, there's no number factor that's common to everything. But there is a common factor, and we can see that if we factor these trinomials. If you think about two numbers that multiply to equal positive 15 and add to equal negative 8, I can factor the top as m minus 3 times m minus 5, because negative 5 and negative 3 multiply to equal positive 15 and add to equal negative 8. And in the denominator, I want a factor pair that multiplies to equal negative 18 and adds to equal positive 3. So the factors, the two numbers are going to have different signs. Positive 6 and negative 3 are going to do the trick. If I add them together, I get a positive 3. If I multiply, I get a negative 18. So since it was a negative 18, I know that they had to have different signs. And since the middle number was positive, I know that the 6 has to be the positive one. So the common factor is staring us in the face. M minus 3, that whole thing altogether is a common factor. Not just the m and not just the 3, but that whole thing in parentheses. M minus 3 is a common factor. And so I can cancel that from the top and the bottom and write the expression more simply as just m minus 5 divided by m plus 6. One more example highlights a subtle thing that's important to realize. 3 minus y over y minus 3, those two expressions are almost the same, but they're not quite the same, right? So reversing the order of subtraction, it doesn't change an expression a whole lot, but it does change it a little bit. And we can see what it does. If I plug in 10, for example, if I plug in 10 for y, 3 minus 10 is negative 7, 10 minus 3 is positive 7. And that's true for any other number we could think of. If I plug in negative 8, 3 minus negative 8 is positive 11, because it becomes 3 plus 8. Negative 8 minus 3 is negative 11. So the difference here is that the number up top is going to be exactly the same as the number on the bottom, but it's going to be the opposite. So I should say it's not going to be exactly the same, but the number up top is going to be exactly the opposite of the number on the bottom for any value of y except for y equals 3. Again, we can't plug in values that make the denominator equal to 0. So if I reverse the order of those terms, if I reverse the order of the terms up top, I get negative y plus 3 over y minus 3. And then, because of that negative sign, well, I might think I could factor out a negative 1. So negative 1 times y gives me negative y. Negative 1 times negative 3 gives me a positive 3. Right, so if I factor out a negative sign from both of those terms, if I take that minus sign and try to kind of move it away, this is exactly the same as negative 1 times positive y and negative 1 times negative 3. And now I can see that what's left behind after I factor out that negative 1, what's left behind is exactly the same. And so that cancels. And this has to do with the fact that any number that I plug in for y up top and in the denominator, I'm going to get opposite values. Any number other than positive 3, I'll get opposite values, a positive value up top and then a negative 1 in the denominator, or a negative value up top and the exact opposite, positive value, in the denominator. So whatever I plug in there, I'm always going to just get negative 1. And so an expression like this, if I have just a reversed subtraction, 3 minus y over y minus 3, those are going to cancel, but they leave behind a negative 1. I hope you enjoyed the video. Thanks for watching.